the moment, we're going to sit and talk about degrees and radians. Now, in theory, you should be reasonably comfortable with the idea that that's my circle, first of all. And second of all, that if I measure the angle inside a circle, I get 360 degrees. That's why it's always funny when people said, I did a total 360 on this. I'm like, no, you didn't, dude. You did a 180. You went from here to here. You didn't do a 360. Anyway, one of the best reasons to know math is so you can make fun of people who don't. That's just what we do. Anyway, degrees and radians. You have 360 degrees in a circle. That's a completely arbitrary measurement. It has nothing to do with anything except the fact that like the Babylonians or something had a base 12 number system. Actually, a much more effective way to measure a circle is with respect to its, circumference. So if I have a circumference of 1, or a radius of 1, the circumference of this circle is 2 pi times the radius. But in my case, the radius is 1, so it's 2 pi. Okay? And so at some point, they decided, I'm really upset at this circle. At some point, they decided, let's quit measuring our circles in degrees, and let's start measuring it in something that's actually legitimate. So now they created a new measurement system called radians. So instead of saying that the circle has 360 degrees, we say that it has 2 pi radians. Now, something important to note is that a degree has a degree symbol because it has a unit. The units are degrees. Now, in radians, you could say, it's 2 pi radians, but actually the units on radians is nothing. These are actually called a unitless measure. So, if I have, 3 feet times 5, that gives me 15 feet. If I have 2 pi radians, that doesn't really count as a unit. So 2 pi times 5 is just 10 pi. There's no feet, there's no units on a radian measurement. So that's kind of important sometimes, and sometimes it's not. It's going to take a while for you to get to a point where that matters, but I did want to at least mention it now so that you got it. Like, when you can remember, oh, somebody tried to explain that to me at some point, and they did a really bad job. But anyway, they do have a unitless measurement. Now, really just getting started with degrees and radians, it's important just to be able to convert from one to the other. So let's make some comparisons of my little circles. So if I've got 360 degrees, I said that's the same thing as 2 pi. Now what if I have 180? If I go half the circle, would it make sense that I've gone half of 2 pi? So if the circle is 360, if I go half the circle, I should go half the radians. So really it's just pi. And this is actually the conversion that we use most frequently, is that pi is the same thing as 180 degrees. Okay, that pi is 180 degrees in radians, or pi radians is 180 degrees. Okay, so in general, you can do this for several pictures if it helps. I could say, well, what if I only go 90 degrees up the circle? If I only go like 1/4 of the circle, then I'm only going 1/4 of the 2 pi. So that's really pi over 2. So 90 degrees is pi over 2 and stuff like this. So you can think about it as being a fraction of a circle. Like I said, usually what we do is we use that pi to 180 ratio. So in general, if I'm going from, say, from degrees to radians, say I have, 30 degrees. I know that pi radians is the same thing as 180 degrees. So what I can do is I can just multiply. It's just like converting units. Pi is the same thing as 180 degrees, so I can multiply by pi over 180. If you really want to get technical about it, you can think the degree sign cancels out, and that's going to give me pi over 6. So 30 degrees is the same thing as pi over 6 radians. So if I've got, 45 degrees times pi over If I want to convert it, I multiply times pi over 180. The thingies cancel out, the degrees cancel out, and I end up with basically pi over 4. So 45 degrees is pi over 4. Okay. Think about if you've got 0 degrees, back to the idea of the circle. If I have 0 degrees, it should be pretty straightforward. I have 0 radians. But if you want, you can go ahead and multiply it out. So times pi over 180 degrees. The degrees are going to cancel out. 0 times anything is just 0. And so on and so forth. Now, going backwards from radians to 2 degrees, again, you can think about it as a conversion. So if I have, pi over 3 radians, I want my final answer to be in degrees. So that means the degrees need to go on top, because I want my final answer to go in degrees. In this case, the pi's accidentally cancel out, but they don't have to. And that's going to give me 60 degrees. Now, you can't always count on the pi's canceling out. You can't always count on the pi's canceling out, because say if I gave you 1.23 radians, there's no pi really. So what you want to think is, okay, in the end I want degrees. So degrees has to be on top. And so that would be whatever that is. So 180 times 1.23 divided by pi. And this is why everyone should have a TI-89, because they're beautiful. So 70.5 degrees. Okay, so radians to degrees is really not about, I was taught that you think about it as canceling out the pi, but what you really need to think about is you need to reintroduce degrees. You need to have the unit of degrees back in there. Now, there are some of these that you're going to be doing so often that you really need to have these memorized. So make yourself a list of stuff to memorize. Okay? You really need to have these basic conversions from 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. It's going to be expected, especially as an engineering student or a math student, that you can go between degrees and radians on these without thinking about it. And ideally, all the way up to 360. So you're going to have some teachers that are going to say, I also want you to memorize, 120, 150. I think I missed something. Oh yeah, 135. Come here. No, you don't want to erase. That's fine. We don't have to. 135. They're going to have you do a whole bunch more of these, etc. But if you've got the 5 basic ones memorized, you're in good shape. Now, this first one should not be too bad. It's just 0 radians. This one, as we established before, is pi over 6. This one's pi over 4. This one's pi over 3. And this one's pi over 2. So we've already shown all of those. But again, it's just one of those things where you're going to be doing it so often. It's just one of those things you really need to have memorized, because you don't want to be in the middle of working a really complicated physics problem and be like, oh, wait a second, how do I convert degrees to radians? That shouldn't even be an issue eventually. That you should just be able to go, oh, 30 degrees is pi over 6, just kind of like one of those things, like converting feet to inches and stuff like that. I'm pretty good at that, probably. So make sure that you commit these to memory so that you're in good shape going forward. And that should really get you started in this whole process.